All right, so we want to recall something about distance between points, which maybe we haven't talked about at all. Is that accurate? Okay. So let's talk about distance between points for just a second. All right, so maybe best done by example. Let's pick two of the points out of problem 39. So say we've got -3, -1, and 4, -4. And I just want to know how far apart these are. Okay? What's your first step in encountering a problem you don't know how to do? Panic. Good. Okay, so once we've panicked a little bit, what's our next step? Read the problem. Okay, I want to know how far apart these 2 points are. What's your next word problem step?
Draw a picture.
Yeah, draw a picture. Which in this case, June turns into graph the freaking points. Right? Okay, so let me graph these 2 points. So here's our kind of usual XY axis. Where do these 2 points go? Okay. Left 3, down 1 is my -3, -1, right? And the other point is right 4, down 4. So it's over here. Okay. I want to know how far apart these are. Where's the picture for how far apart are these?
A straight line.
Okay. I should have a line in between them, right? Like this. This is the distance I'm interested in knowing, right? Do I have a tool for this? Do you guys see a tool for this? Yeah, there's a triangle here, right? There specifically is this triangle, right? Yeah, and then that's the hypotenuse, right? So I want to know about the hypotenuse. Do I have a tool for that? Yeah, I know the Pythagorean theorem. Does the Pythagorean theorem work here? What do I need to know about the Pythagorean? I need to know the length of the other 2 sides, right? And also, what do I need to know about the triangle? Yeah, it has to be a right triangle. So is there a good reason that this should be a right angle here? Why? It's a graph, yeah. And this side is parallel to this axis, right? And this side is parallel to that axis. And there is a right angle here. You guys see that?
Yeah.
So if these 2 things hit at a right angle, then those 2 things which are parallel must hit at a right angle. You guys cool with that? Okay, so I know this is a right triangle. Now I want to know how long are these sides. Okay, so can you count for me? How long is this side?
-3.
Yeah. So -3 actually almost makes sense there, right? Because it's going down 3 units. If I was calculating a slope, right, then that would actually be negative. How about this other side? How long is that? 7. Cool. All right. So then what should I do with these? What am I doing with 3 and 7?
Plugging them into the Pythagorean theorem.
Okay. So I'm going to make a, I should probably make up a name for this thing. It's supposed to be the distance, right? So I'm going to call it D to be confusing, because D and C are quite close together, right? So what do I know? What's the Pythagorean theorem tell me? It tells me
plus b squared equals, in this case, d squared.
okay, so D squared, right, is going to be, what are A and B? 7 and 3. So I got 7 squared plus 3 squared. Yeah? Okay. How do I find D now? Solve for D, right? Okay, so how do you solve for D here?
Square both of them, add them together, and then square root.
Okay. Square both of these things, right? 7 squared and 3 squared. Add them together, and then square root that whole business, right? So the thing I did to get from here to here was square root both sides.
Yeah.
What did I fail to do that I usually do here?
Actually, multiply out 7 squared.
Yeah, I've failed to actually compute, right? But what else have I not done that I usually do? Me personally. Have you guys seen something up here that I usually do that I haven't? Yeah, I don't have a plus or minus here. Why don't I have plus or minus here? Yeah, we already laughed, right, about a negative. Yeah, negative distance doesn't make any sense, so I'm going to pitch the negative half of the square root, right? So here, in this particular problem, I've got d as the square root of
9 plus 49, which is 58.
perfect. 58. 58 have a convenient square root?
No.
Nah. Okay, so I'll probably leave it as 58.
Somewhere between 7 and
Yeah. Is cool with this? Okay, so there's my distance check, right? This was a little bit convoluted. Maybe we should make a shortcut. You guys want to see a shortcut for the distance formula? Or for this idea? It's called the distance formula. Okay, so d is the square root, and there's something squared plus something squared. Yeah, how did I get these? What did these 7 and 3, where did they come from in there?
the difference of the 2 points, right?
Yeah, kind of. So to get the 7, right, what did I do? I took how far this is, right, and subtracted how far that was. Okay, see that? I wanted to know how far it was in x from here to here. So I took where I ended and subtracted where I started. So I'd write that as x2 minus x1. You see that?
Yeah.
It's just the second x coordinate, subtract the first x coordinate. How about in the y's? What did I do in the y's?
Same thing.
Yeah, the exact same thing. Took y2 and subtracted y1. And then why aren't I worried about negatives? That's what you're
Because
asking.
they're both distances, so they have to be positive.
No negative.
Yeah, but why aren't I worried about getting negatives in here?
No negative. Well, because you're going to square it.
Yeah, I'm going to square it anyway, right?
You're gonna square it.
If you guys fiddle with this one, you'll realize that here we'll get the 7 that we got, and then here we'll get -3. But I'm going to square it anyway, so I'll get that same 9 that I got before. You guys okay with that? So this is a shortcut. This is your distance formula. This thing does, right, the thing you should think when you see this, is this does the distance between points x1, y1, and x2, y2. Guys cool with that? Any questions on this one?
Yeah, what's the third one for?
Let's do problem 39 in a second. Anybody confused at all about this? This distance formula, Gizmo, is just the Pythagorean Theorem. So if you forget it, just draw the picture and do the Pythagorean Theorem to it. Cool?